Okay, um, today we're going to be looking at the new topic called geometry distribution. Okay, geometry distribution. Again, this is a discrete random variable. Okay, so let's look at the syllabus, what it entails or what it contains. Okay, it is part of discrete random variables. Okay, we have done binomial before, so now it's geometric distribution, and I plan to go back to the um, distribution table related drawing probability distribution table later after this, because it's a short unit and it's a nothing difficult, so I thought we can do that later. Okay, so now today's focus is today and maybe next couple of lessons will be more on geometry distribution. Okay, let's look at that. Okay, a variable is a quantity whose values changes. Okay, a discrete variable is a variable whose value is obtained by counting. Okay, discrete. For example, number of students present, number of red marbles in a jar, which you can count. Okay, and then number of heads when flipping three coins. Okay, and then students' grade level. Okay, whether it's A or B or whatever. Okay, you can count that. Whereas a continuous variable is a variable whose value is obtained by measuring. Okay, height of a student in class, weight of student in the class. Okay, time, height. We know we cannot say someone is exactly 2 meters or 3 meters. You cannot uh, quantify that way. It has to be to a certain centimeter, or in fact sometimes even to a certain millimeter. Okay, so and also same goes to weight, to a certain gram or kilogram point something. Okay, so this is why it's known as continuous variable. A random variable is a variable whose value is a numerical outcome of a random phenomenon. Okay, random variables denoted by capital letter. The probability distribution of random variable x tells what the probability value of x. Okay, whenever we will be seeing this. Okay, p and then followed by x, meaning we are looking at what is the probability of x. Okay, and then a random variable can be either discrete or continuous, but our focus is more of discrete. Okay, for this unit. Okay, example of discrete distribution. Okay, there are very many. Okay, I've listed down a few. Poisson, binomial, Bernoulli, multinomial. Binomial, we will be learning. Bernoulli is part. Actually, Bernoulli binomial is part of Bernoulli. Okay, Bernoulli is basically trials. Okay, so many trials until you get trials which has success and failure. Okay, discrete whereby Poisson and multinomial we won't be doing that, but it's in S2. Discrete data can only take a particular value in range. Okay, continuous data can take any value in a range. Okay, discrete data usually arises from counting, while continuous data usually arises from measuring. Okay, one is counting, the other one is measuring. Okay, you got to note that. Okay, I've given you two examples here. How tall is a plant given a new fertilizer? Okay, how tall is a plant given a new fertilizer? That's continuous. This is something that you can measure, meaning a tall, the height of the plant, you can measure to the nearest centimeter, or sometimes even nearest meter. Okay, so depending on the what type of plant, so you can measure that. So we can say to the nearest, maybe we can say 1 meter and 30 centimeter. Okay, or we can say maybe it's about 5 meters and point something centimeter. Okay, so that is what it means by continuous. Whereby the next one, how many rats are on an oil palm tree estate? Okay, oil palm tree estate. Okay, how many rats are there? In Malaysia, we know there's so many oil palm estates, or not just oil palm. We have rubbers, but rats are quite rampant, or I mean predominantly living in oil palm estates. Why? Because they love to eat the oil palm seeds. Okay, especially when they are tender and young. Okay, so they love to eat that. So what people do is, all the farmers, what they do is, they'll try to kill the rats before any harvest. Okay, otherwise, they're going to lose a lot. Okay, by not producing good, oil palms or oils. Okay, so we have to kill the rat in that case, and we have to count how many rats are there if you want to do a survey. So this rats are known. These rats can be counted. Okay, you can count them rather than measuring. Okay, you can't measure rats. Okay, because they are one individual. They are not point something. So if you have a variable and can find a probability associated with a variable, it is called a random variable. In many cases, the random variable is what you are measuring, but when it comes to discrete random variable, it is usually what you are counting. So for the example of how tall is a plant given a new fertilizer, the random variable is the height of the plant given a new fertilizer. Okay, for the example of how many rats are on an oil palm estate, the random variable is the number of rats. Okay, the random variable over here is the number of rats. So bear that in mind. Whereas for the fertilizer is the height. Okay, so I hope this is clear. This is just basic understanding. Okay, what is discrete distribution and random distribution. Now we'll look at more in detail. So geometric distribution is um, discrete random variable. Okay, but what is geometric distribution? Okay, geometric distribution describe a sequence of trial, each of which can have two outcomes, success or failure. Okay, you can have only two, one is success or one is failure. Excuse me. Trials are continued indefinitely until first success is obtained. Okay, I'll explain this in a bit. And then simple example is tossing a coin when we get a hit. Okay, this is what we mean by trials are continued indefinitely. For example, let's say I have a coin. Okay, I'm going to toss. I want to toss the coin until I get the first eight. Okay, first head. Okay, so you're going to toss. Okay, let's say you take a 10-cent coin or 20-cent coin or whatever coin, and then you start tossing. Okay, first it's my turn, no hit. Okay, and then somebody else goes. Okay, maybe he tries to get the hit, he doesn't get, and then I keep trying, and then he goes until the first person, okay, gets the hit. So if I'm doing it, okay, maybe I didn't get it. Maybe I've tried for 8 times and I've got it only on the eighth time. Okay, I've been trying and trying. I only got it on the eighth time on first hit. So my first hit appearing, okay, after tossing for 8 times is on the eighth turn. Okay, I'm only getting the hit on the eighth turn. So that all the turns, all the other times, okay, I've tried 7 different times. Okay, in these 7 times, no hits appeared. Okay, I didn't get hit. All I got was tail. So, but on the eighth, I got a hit. Okay, so basically, geometric distribution describes a sequence of trial, each of which can have two outcomes, which is success and failure. So you can have success and failure, but trials are not fixed. Okay, unlike a binomial, okay, the trials is not known in advance or not fixed. Okay, we cannot just say that I'm going to do 10 trials. No, you can't say that. Okay, because in geometry distribution you try until you get your first outcome, depending on what you're doing. If it's a dice, okay, let's say I want to roll and I want to try to get a 5. Okay, so I'm rolling once, twice, third, fourth time I've got it. Okay, a 5. So the first 3 times you didn't get a 5. Okay, it's a complement of 5. Okay, it could be 1, it could be 2, it could be 3, it could be 6. Okay, it could be 4, but not 5. So those are the complements. So on the fourth time I got a 5. Okay, so your trial is done indefinitely until you get your first outcome. Okay, depending whether it's a coin or a dice or anything else. Okay, so let's look at first example. Okay, what is the probability of getting the first 4 in sixth attempt when a die is rolled repeatedly? So meaning on the sixth attempt you are getting, okay, assuming on the sixth attempt you are getting, you roll a die, okay, keep on rolling, but only after the fifth time, on the sixth time you are getting. So first 5 you didn't get, so it's a complement, okay, of 6. So we know the probability of getting 6 is 1/6. Okay, probability of getting 6 is 1/6. So probability of getting the complement of 6 will be 5 over 6. So for the first time when you roll, you got 5 over 6, then second time you got 5 over 6, third times you got 5 over 6, the probability I'm talking about 5 over 6, fourth 5 over 6, fifth 5 over 6, but on the sixth you got 1 over 6 because you already attained the 4, okay, which you wanted. Okay, that's what it meant. Okay, and then same goes, let x be the number of birth in a hospital until the first boy is born. Find the distribution of the function x. Okay, a person is aiming to shoot bullseye in a dartboard game. Okay, what is the probability that he will hit the bullseye on his 10th attempt? So meaning on the 10th attempt you already got a bullseye. Okay, so first 9 he didn't get anything. Okay, it's a complement of the outcome of the 10th attempt. Okay, so if the 10th attempt is a probability of getting is, let's say, bullseye is 0.1, then for the first 9 he's been only getting 0.9, which is the complement, not getting, okay, the bullseye. Okay, I hope this is clear. Okay, let's have a look at the next slide. Okay, these are the formulas, okay, whereby p bracket x equals to r, and that is equal to q to the power r minus 1 p, where r equals to 1 to 3 4 and q equals to 1 minus p. Okay, let me explain a bit. What is p, what is r? Okay, r is basically number of trials. Okay, let's say you have tried 6 times, on the 6th time you hit. Okay, so q will be the outcome, probability of not getting a hit. Okay, whereby p is the probability of success, okay, getting a hit, and then q is the probability of failure, not getting a hit. And you don't have to know what is q. By knowing p I can find out what is q. Okay, and then you have mean is mu, which is the expected value, 1 over p, and variance equals to variance equals to q over p square. So it should be sigma square, not sigma, guys. Okay, I'll fix that. It's sigma square. Okay, it should be sigma square. Let me fix that. Okay, because we're talking about variance. Okay, it's sigma square. Okay, it's not sigma. Okay, so so that's what your formula is. Okay, so now yeah, basically that's it. Okay, before I go to this first example, okay, make sure you understand this. Okay, so maybe I'll write it over here. Like, okay, so variance equals to sigma square equals to var x equals to q over p square. Okay, q over p square. Okay, let's say if you have a die, okay, or dice, okay, and then you want to your aim is to get a 5. Okay, to get a 5. Okay, you're trying your first throw to get a 5. Okay, your first throw, it could be 5 or not 5. Okay, if it's not 5, then you will go to your second throw, which is a 5 or not a 5 again. Okay, on your second throw or on your second try, you're still not getting 5, you will move on to the third throw. Okay, again not 5, and then a 5. These are the two possibilities. Every time when you throw, these are the two possibilities. And then let's say you're still not getting, so you'll move on to the fourth try. Okay, you get a 5 or not 5. Okay, so you can keep going until you hit your target. Your target is to get a 5. Okay, if you don't get a 5, then you're going to keep going. Okay, this is what geometry distribution is. There's no fixed trial. Okay, we don't know how many try we're going to do. Okay, unlike binomial, we can have, okay, this many. Okay, from there we can find out whether we're going to hit or not. Okay, or even defects or not defects. Okay, if a company produces this many 1000 parts, okay, how many defects that you can find, provided given a certain probability of defects and not defects. Okay, but unlike a binomial geometry distribution, there's no such thing. Okay, so the trials are not fixed until you find what is the value, until you get your target, until you hit your target. Okay, and then number two, it is independent. If you look at it, okay, the probability to get 5 is 1 over 6, and probability of not getting a 5 is 5 over 6. Again, 1 over 6, 5 over 6, 1 over 6, 5 over 6, 1 over 6, and 5 over 6. So it just keeps going. So these are independent, okay, to one another. And if you look at it, one trial doesn't influence the other. Okay, because the first trial, if you don't get it, you can keep moving to the next one, okay, until you hit your target, and it doesn't influence whatever that you got before. Okay, the only thing that influence is, if you don't get it, you will keep trying. That's all. Okay, I hope you're fine with this. So from here we can deduce a formula. Okay, so formula is binomial expression or distribution, sorry, geometry distribution, x equals to r. So to get your target, okay, until you hit your target, so your probability, let's say 1 2 3 fourth time, you already got it. So if it's on the fourth time, then it will be p x equals to 4, because on your fourth trial you already got your 5. Okay, so before that, your first 3 tries you didn't get it. So since you didn't get it, okay, this is 5 over 6 is the failure. So failure is 5 over 6. Okay, and how many? To the power of 3. And then this is multiplied by the fourth time you already got a 5. And what is the probability of getting 5? 1 over 6. Okay, so this is your formula, and from there we can work it out, the answer. Okay, I think you guys can do that. So based on this concept, I can find out what is the formula, the general formula. So the general formula is p x equals to r equals to, this is 5 over 6 is the failure, so failure is represented by q, r minus 1. R minus 1 is the number of trial. Let's say you have got your 5 on the fourth trial, so it's 4 minus 1, and then this is multiplied by p. Okay, so that is your general formula, where q is failure, okay, and p equals to your success. Okay, thanks.